How to stop the melt. You are watching here the Arctic and the Antarctic ice sheets and how they are fluctuating throughout one given year. The months are going by from January all the way to December. This is 2016. Let's just focus on the Arctic, not through one given year, but across many years, from 1979 all the way to 2022. Clearly, the Arctic ice cap is shrinking. In this video, I will use the following phenomenon, our polar ice sheets shrinking, as a segue into a set of heat labs. Basically 3 labs. In this video, I'm only going to focus on the first of these 3 heat labs in one document, namely the heat of fusion. That's melting. When is that ice cap going to be gone? Using data recorded by the GRACE-FO, which stands for Gravity Recovery and Climate Experiment Follow-on, which is a partnership between NASA and the German Research Center for Geosciences. Science Daily recently released an article stating that in 10 years, we may be ice-free on the Arctic. The primary resource of this publication was in a Nature Communications article, coming from a study done by scientists in South Korea. Let's put that satellite data into graph form. If we're looking here at the Arctic data, we can clearly see a downward trend of the Greenland ice mass. And it says the rate of change is roughly 271 billion metric tons per year since 2002. How can we make sense of this data? That would be the equivalent of close to 9 Eiffel Towers vanishing per year since 2002. Again, this is the Arctic. What's happening in the Antarctic? The Antarctic ice mass is a little bit more complicated, but we do see a relatively downward trend over time. Roughly the equivalent of 5 Eiffel Towers per year, 147 billion metric tons since 2002. Clearly, ice is melting. How can we now bring this phenomenon into the classroom and enable our students to understand this from an energy amount? The first of 3 heat labs has students experimentally measure the heat of fusion of ice. To follow the next generation science standards, this is going to be a lab that has very few directions and is more student inquiry based. These are all the materials that they're getting, no directions. Looking at the actual document, all that my students will be given is a data table. That's already a lot. And based on what's in that data table, they got to figure out what are the important measurements and how should they be taken most accurately, having access to the following materials. The key shows you that students can figure out themselves how many ice cubes should they actually add to the calorimeter. Is more better than less? So I'm showing you here 2 sets of data, one using 5 ice cubes, obviously depends on the size, one with only 2 ice cubes. Take note of the percent error, a slight underestimate when using 5 ice cubes, and a more significant overestimate when using only 2 ice cubes. And the explanation for that, well, a couple of key errors that I want to highlight. Obviously, the obvious error is, first of all, that some of the warm water in the calorimeter is not going into melting the ice, but instead some of it is transferred into surroundings. That would lead to an overestimate. Another error can be attributed to the fact that some students will not immediately measure the temperature of the water in the calorimeter just before they're adding the ice. So if you wait too long, the water will have already cooled down before adding the ice into the calorimeter. Consulting with ChatGPT gave another interesting reason, and that might be the incomplete melting of the ice. So perhaps students are measuring the final colder temperature too soon. Not all the water molecules have actually been separated. Not all of their hydrogen bonds have been broken. And another possible reason might be that if you're using tap water compared to distilled water, impurities in the water may influence the speed of melting and the temperature. These impurities may only have a minor effect on the percent error, but these impurities enables you to connect the heat of fusion calorimetry experiment to colligative properties of solutions. Take a look at the key document and see what you think. For your reference, these are the Next Gen Science Standards and the New York State Science Learning Standards. And if you're looking for any other natural phenomena, this video linked above centers around the Canadian forest fires that have been affecting our air quality as measured by the Air Quality Index. If you want all Astrid's science resources, go to the link in the description below and they can be yours to keep at no cost to you. You are welcome. What a great way to start the concept of heat by connecting it to global warming, or should I say climate change, or should I really refer to it now as climate crisis? How to stop the melt. One way is to teach our students all about heat, and this is the first of 3 labs that enable students to experimentally measure the heat of fusion. Stay tuned for the next video, which will be the second of 3 labs in one. This second lab will focus on the specific heat of a metal. Thank you very much for watching. Bedankt voor het kijken and see you in the next video. Tot ziens!